now reviewed the definitions of mean, median, mode, and range. We've also learned about standard deviation. What is standard deviation? The average distance from the average. So, where are we? Sometimes we need to know more about where a particular number fits in a list of data. Other ways to do this include using quartiles or percentiles. We will begin with a quartile. A quartile represents 1/4 of the numbers in a list. So 1/4 of the numbers in a list. So obviously there are 4 quartiles in any list. To find the quartiles, we line up all the numbers, and then we find the middle number known as the median. So I'll call that number the median. And then I look at the minimum, and I find the median from the minimum to the median. So I find another middle number, and I do the same on the other side. And that splits the group into 4 smaller groups of equal size. Kind of. They're sometimes equal size, sometimes they're not. So this first set of numbers is called quartile 1. It's the lower 25% of any list. The highest number in that set we refer to as Q1. Quartile 2 is every number between Q1 up to the median. Quartile 3 is from the median to this larger division, and we call that larger division Q3. And then the last quartile is quartile 4, and it ends at the maximum. So really there are 5 important numbers: minimum, Q1, median, Q3, and the max. And your calculator will actually find these for you, but we're going to do a couple by hand. So Q1 represents from 1% up to 25%. Q2 is from 26 to 50. Q3 is 51 to 75, and Q4 is 76 to 100%. And there's a number we use quite a bit called the interquartile range. The interquartile range, oh, I messed that up, didn't I? Is the distance from Q1 to Q3. So to find the interquartile range, you look at Q3 and you subtract Q1, which is the range of the 2 interquartiles. So Q3 minus Q1. That's how we find it. Now, if there are 8 numbers in a list, it's really easy to pick the quartiles. So in this first one, there are 8 numbers, so the median is going to be right there. What's the value of the median? 6.5. So Q1 would be right here, which is 5, and Q3 which would be 7.5. And then quartile 1 is represented by the lower 2 numbers. That's quartile 2, quartile 3, and quartile 4. So what is the interquartile range in this case? What is Q3 minus Q1? 2.5. It becomes a little bit harder when there are not, when the number in the list is not divisible by 4. But on this next list, oh, sorry, 2.5. The next list, if I count in, then I end up with 19. Did I do that right? So 1, 2, 3, 4, 5. 1, 2, 3, 4. Shoot, 1, 2, 3, 4, 6, 7. 1, 2, 3, 4, 5, 6, 7. 19. Okay. So 19 is the median. And then I have to find the median of either side. So I'm going to count in 1, 2, 3, 1, 2, 3. So 12.5. 1, 2, 4. I think I messed something up, right? 12. There we go. 12 and 22. So the interquartile range is going to be 10. Now those were pretty easy because the medians were easy to find. But what if I had 5 pieces of information? 1, 2, 3, 4, 5. Well, there's the median. So where do I put quartile 1? Well, if I put it here, then there are 2 numbers in Q1 and 1 number in Q2, and it's kind of a mess. And nobody can really agree on how to do that. There are actually 3 methods to find the quartiles. Sometimes you include numbers, sometimes you don't, and you kind of pick what method you like. So because of that, we're just going to use the method that the calculator gives us. So if there are a funny list of numbers, we'll just ask the calculator, and it will find Q1, Q2, Q3 for us, so we don't have to. So if you look at the next problem down, let's put number 6 in our calculators. Edit. And the list is not in order, but the calculator doesn't care. You can put them in any order you would like. And then do one variable stat. Maybe. What is x bar? The mean. Which one of those numbers represents the standard deviation? Little sigma x, lowercase sigma x. And then if we scroll down, it lists the minimum, which is the smallest. Q1 is the biggest number in quartile 1. The median is the biggest number in quartile 2. Q3 is the biggest number in quartile 3, and the maximum is the biggest number in quartile 4. So we labeled the quartiles as 7, 11, 15, and 18. And the minimum is not listed. What would the interquartile range be? It's 15 minus 7, which is 8. In which quartile are the following points? Where would 4 land? In quartile 1, Q1, 17. Well, it's bigger than Q3, and Q3 is the largest number in quartile 3. So it's going to be 4. And 12? It's between 2 and 3, which means it's in 3. That's pretty simple, right? Okay, turn the page. These graphs are called histograms. There are 2 types of histograms. Do you remember on the core test practice there was a question about histograms? Well, now you'll know. There are 2 types of histograms. A frequency histogram, in which you make a bar graph that represents the number of times a particular thing happened, like the number of people who are 50 inches tall, or the number of people who got 8 on the ACT, or something like that. Okay? So the bottom is always the score, or the height, or whatever it is you're measuring goes on the bottom. And then on the side is the frequency, the number of times it happens. The other way to do it is a relative frequency. A relative frequency does not graph how many times something happens, but what percentage of the total that represents. So the one we're looking at now is a relative frequency histogram. The funny thing is, the shape of a relative frequency histogram and a relative histogram, a frequency histogram is exactly the same. So if we look at this graph and we say this was the score on a national test, 15% of the people got a 1. 10% of the people got a 2, and so on. Well, if 1,000,000 people took the test, how many people scored a 1? This would be 150,000. This would be 100,000 and 50,000. If I were to change the percentages to actual values, is that going to alter the graph at all? No, it's still going to look exactly the same. So whether it's a frequency histogram or a relative frequency histogram, you're going to end up with the exact same shape. Just the labels of the y-axis are going to be different. Okay? We now need to learn about percentiles. As can be guessed from the name, a percentile divides a list of numbers into 100 equal groups, where each group represents 1% of the numbers in the list of data. So you see here a bunch of percentages. If you add up all those percentages, they should equal 100%. If they haven't, then we either made a mistake or there's part of the graph that we're not looking at. And percentiles go from 0% up to 99%. And the reason that's the case, percentiles tell you out of 100 how many students you beat. So if you're the 70th percentile on the ACT, so say you take the ACT and you get a 27, and they tell you that's the 78th percentile, which means you scored better than 78 out of 100 people. So if you score in the 99th percentile, that means you scored better than 99 out of 100 people, and you are the 100. Does that make sense? If you're the worst person, then you're a 0. If you're the best person, then you're a 99. So percentiles are a little strange that way. So if you ever score 99 and you're upset with yourself that you didn't beat everybody, rest assured you did. So these problems say, from the graph above, determine which number represents the given percentile. So let's suppose that I am in the 26th percentile. What was my score on the test? Well, I just need to count the percentages. How much is that? 5, 10, 15, 20, 25. So this was 25, and this is 30, so 26 was right there. So somebody in the 26th percentile would have scored a 3. What about the 96th percentile? Well, you have to be careful with the 96th, because what is this number here? It's 99. So that one would be 94. So it's got to be somewhere in between 94 and 99, which would be an 8. So the top of the lines count, and the bottom of a line does not count. Because you could say that this is 25 and that is 25. But you can't be in, you can't score a 2 and a 3 and be in the 25th percentile. It's a 2 or a 3. So if it lands on a line, it's always the top and not the bottom. Okay, 43rd. Well, we're up to 30, so what would this line be? 35, 40, 45, so it's a 5. And the 70th percentile, so here's 35, 40, 45, 50, 55, 60, 65, 70 would be a 6. Okay? Any questions about these? If you look at the next one down, this is still a relative frequency histogram, but instead of percentages, they've just given us the decimal. So how would we find the 38th percentile? So that's 4, 8, 12, 16, 20, 28, 32, 36. So that was 40. So 38 would be an 8. Okay. You guys are going to have plenty of time to do all of these. I'll put the answers up on the board. Good luck.